In this lecture, we're going to go through a fundamental mathematical operation referred to as a summation operation. And these are the operations that we will be using quite often with the various statistical procedures that will be addressed throughout the course. And we begin with the symbol uppercase sigma that you see here, Greek letter sigma, and this is the symbol that is just simply referred to as the summation operator. And when we use this symbol mathematically, that indicates that we are going to perform arithmetic addition, and the symbol that you see here with these other factors related to it provides a very convenient way of spelling out a particular operation that needs to be conducted, particularly when we have relatively large sets of numbers and we want to condense the operation without having to write out every number. But we'll go through a number of examples in this lecture. On the bottom of the summation operator symbol, the sigma symbol, we see I equals 1. This is referred to as the index of summation, and this will provide the instructions on how to carry out the addition operations. Now, the way this is done is to replace I in the variable that precedes the sigma symbol by a number that goes up to n. And so what we're doing here with our variable, note that we have x, which is just a placeholder, subscript I, which means that we will replace the I by integers from 1, because the index of summation suggests that we now start to add the numbers. Starting with the number 1, we replace the x of I with the number 1, and then we continue to do that for the number of integers up to n integers. Now we're going to start with an example here. So here we see sigma, the summation notation, with the index of summation starting from 1 up to 3. So we're going to substitute xi with 1, and then we're going to add that to the next number after 1, which would be a 2, and then we would add that to the next number following the 2, which is a 3, and we stop at 3. And so in writing this out, what we have is that the instruction here is to begin with the number 1, add the number 2, and add the number 3, and we stop at 3 because the symbol indicates that that's where we're going to stop. And we carry out the arithmetic addition, and we get a final answer of 6. In our second example here we see something very similar to our first example, except that our variable is raised to the power of 2. So obviously the 2 is not going to be changed, but the x sub I will change based upon the instructions of the index of summation here. So at this point, pause this video and complete this operation as we did up here at the very beginning, and then when you're done, restart the video and I will show the solution to this particular problem. Okay, presumably you've had a chance to write out your solution, and what we see here, we begin with substituting 1 into x sub I. That number is going to be squared, and then we're going to repeat that. We're going to add that to the number following 1, which is a 2, and then we do that with the number 3, and we stop at 3 because in this particular problem we're limited up to and including the number 3. And once again here, the square term doesn't change. That's going to be a constant all the way through. So we substitute 1, so we have 1 squared. We then add that to the next number following 1, which is a 2 squared, plus the 3 squared, and we stop at 3. We carry out this operation and we end up with the number 14. So third example here, make note of the index of summation. Now we see an index that starts at the number 3. It doesn't start with the number 1. And this will go up to the number 5. And what we're going to add up here, our variable, is 1 over I in this case. So once again here, pause the video, go ahead and attempt this problem, restart the video so we can see the solution. So starting up the video again, we begin by substituting the number 3 for I, so we would have 1/3. We're then going to add that to the next number following 3, which would be a 1 over 4, and we continue that sequence until we get to the number 5. And so we end up with a 1 over 3 plus 1 over 4 plus 1 over 5. And that gives us a number that ends up with a fraction of 47 over 60, and that would be the final answer. Now we see something a little bit different here. Here we have a term here which is x sub I minus 4, and our index of summation tells us that we're going to start this from 1 and we're going to continue up to the number 3. And so the 4 doesn't change, the negative sign or the subtraction sign doesn't change. We only substitute for the variable, which is a placeholder. So once again here, pause the video, go ahead and attempt this sequence and restart the video for the correct answer. Okay, so starting up the video, we'll always start with the number 1 or whatever the index of summation instructs us to start with. So we would substitute x sub I for 1, and then we would add this entire quantity to the next term, which would be a 2 minus 4, and then we would continue that process until we get to the number 3. And that's what we have here. So we substituted 1. So we have 1 minus 4. These are in parentheses, so we carry this forward all the way through our sequence until we get to number 3. And we add that to 2 minus 4 plus 3 minus 4. We follow our order of operations and we take care of everything inside the parentheses first. So we have a negative 3 plus a negative 2 plus a negative 1, and we end up with a final answer of negative 6. One more example here in this video. Now we have something a little bit more complicated here. We have this complex equation, and we have our index of summation that begins with 1, so we're going to stay consistent with the previous examples, and we're going to take that up to the number 3 here. And once again, we just treat this entire equation because it's contained within the parentheses, which means that we're going to carry out our summation operation on the entire equation, substituting first the number 1 for our variables, xi, xi, xi. Don't get thrown off by the power raised to the power of 4, raised to the power of 3, raised to the power of 2. Obviously there's no variable with the 5, so the 5 stays put. And one more time, pause the video and go ahead and attempt to complete this, and we'll see where you are once you resume the video. Okay, so starting up the video once again, we substitute the 1, so we have 4.3 times 1 raised to the power of 4 plus 8.4 times 1 raised to the power of 3, subtract 17.1 times 1 raised to the power of 2 plus 5. We then add that entire quantity, so note that I bring in square brackets to contain all of this, all of these terms together before adding it to the next term. And so once again we see the 4.3, we we multiply that by 2 raised to the power of 4 plus 8.4 times 2 raised to the power of 3, subtract 17.1 times 2 raised to the power of 2 plus 5. So the only difference between this first term and this term here is that we're substituting the 1 for x sub I, then we substitute 2 for x sub I, and we treat the entire equation as 1, and then we add it to the next one, and then we add it once again to the next equation with the 3 inserted for the x sub I, and we stop at 3. The 3 could be any number. It could be 10, it could be 100, it could be 1,000, it could be 1,000,000. And in that case, you would just continue this operation where you, using the order of operations, perform this calculation, add that to the entire quantity in the second term and to the entire quantity in this third term. So what you see here is that by using the summation notation, the summation notation provides a much more compact, convenient way of expressing a mathematical operation instead of writing it out this way. And if the number 3 was a much higher number, then you could imagine how much more extensive this would extend in writing it out. So this ends our video on the review of summation notation.